Alright, so our next problem asks us find the perimeter and area of a square that has a diagonal of length 8. Alright, so that's a little bit more interesting. So let's draw our diagonal. And this diagonal has a length of 8. And let's just label some of the points. Well, we know all the angles are right angles. And all the sides are the same. Alright, well that means we have an isosceles right triangle, which means these two base angles here and here have to be the same, which is 45 degrees. Isosceles right triangle is a 45, 45, 90 triangle, which means that we have the following ratio, x, x, and the hypotenuse is x root 2. So, if 8 is equal to x root 2, then to find our side x, we have to divide by the square root of 2. And that involves, when we have the square root of 2 in the denominator, we want to multiply by the square root of 2 over the square root of 2 to get the square root in the numerator. And this part is going to simplify as 8 root 2 over 2. That's equal to x, because the square roots cancel out. And 8 over 2 is going to be simplified as 4 times the square root of 2. So this is what our side length is equal to. 4 times the square root of 2. So each side has that length. And if you're a little unsure of the math, just go back to the lesson on special right triangles and specifically the 45, 45, 90 triangles. Now, we can find the rest of our problem. The perimeter is 4 times the side length. So you have 4 times 4 root 2, which is really just, well, 4 times 4 is 16, and keep the square root of 2. So that's our first answer for perimeter. Now the area is the side length squared. So what we're going to do is 4 root 2 squared. Well, 4 times 4 is 16. Square root of 2 squared is 2. So we are left with 16 times 2, which is 32. And those are the two answers that we need. So, all these things we learned about with squares so far, we have learned that the perimeter is 4 times the side. The area is the side length squared. And when we make a diagonal, it creates two 45, 45, 90 triangles. So if we have the length of the diagonal, and we call that lowercase d equals s times the square root of 2. And the perimeter actually ends up being the diagonal times 2 times the square root of 2. And the area equals the diagonal squared over 2. Well, that's interesting. Let's look at how that actually works in our problem. So we have our diagonal. So let's pretend we don't know what the side lengths are. In fact, let's get rid of all this excess information. And let's just say I know what the diagonal is. I know it's 8. Well, what did we do to find the perimeter? It ended up being 4 times 4 times the square root of 2. Now, if I take my diagonal, 8, and multiply it by 2 times the square root of 2, well, it ends up being the same exact thing, 16 root 2. Now, what is the reasoning for this? Well, it is a 45, 45, 90 triangle where all these lengths are x, and this is our x root 2. And when we do work out the math, that means that length of the diagonal, and let's pretend like it's not even 8. Let's pretend the diagonal length is d. So d equals the side length times the square root of 2. And if we simplify it a little bit, we would find out that d times the square root of 2 over 2 is equal to the side length. This is just the same process we did before. And if we know that the perimeter equals 4x, well then 4 times d root 2 over 2 simplifies, because 4 over 2 is just 2. So we have 2 root 2, and I ran out of room, but you have to multiply that with your diagonal length. That's just how the simplification works. It works every time. And the same thing can be said with the formula for area. So if we think about, well, now we know that x is d times the square root of 2 over 2. Or we can even rewrite this like in the following way here. Then that means the area, which is x squared, which is d times the square root of 2 over 2 squared, which is d squared times 2 over 4, which simplifies to d squared times 1/2. Or, like how they wrote it out in the theorems, d squared over 2. Same thing. So that's how we would develop the formulas that we see here, and even here. So it's all just a consequence of the special right triangles that we learned about a long time ago.